Hi and welcome to the National Home Builders Registration Council's Simplified Home Building video series. I'm Simplified. This video series is based on the NHBRC Simplified Home Building Manual, which has been produced to help you understand what you need to do to comply as a registered home builder. In this episode, we'll be looking at the building process from the foundations to the roof. The process you'll see is based on a house that complies with the minimum deemed to satisfy rules and the standards of the NHBRC, together with the national building regulations. This covers the actual step-by-step process, highlighting the best practices for some of the more critical aspects that can affect accuracy in building work, related to site works, foundations, superstructure, and roofing. Before we start unpacking the building process from start to finish, there are some basic dimensions that must be adhered to, which are outlined in the South African National Standards 10400 Part C. The whole floor area of a home must be 30 square meters or more. Any other room that a person is living in must not be less than 6 square meters. The minimum ceiling height must be 2.4 meters, with at least 1.8 meters clear after the floor has been installed over an area of 6 square meters. Passages, entrances, bathrooms, toilets, and upper floors must have a minimum height of 2.1 meters. SANS 10155 Accuracy in Buildings outlines the method of measurement and the accuracy of dimensions required for the setting out and completion of building work for concrete work in foundations, concrete work above ground, masonry reinforcement in masonry, drainage, trusses, and finished floors. There are some tolerances allowed. This means the amount you can deviate from the measurements indicated on the plan. These are outlined by the NHBRC, measured in millimeters. This table is an example of some of the tolerances, also known as deviations, from the position on the plan to length, height, levels, and so on. Before any work can begin, the site must be surveyed by a land surveyor. This will give you the site boundaries, contours, building lines, services, and restrictions, and will be placed on the surveyor's general diagram, usually referred to as an SG diagram, as you will have seen on the site plan in this video series. Here you can see a land surveyor checking the fall of a site. This will give you information like how much cut and fill is required to make the site level and ready for building. Remember that it is extremely important to have a geotechnical investigation and soil test done to be able to design adequate foundations. From the site assessment, you will know how to clear the site and what is needed to be done to get ready for the next step, which is setting out the house. Setting out the site boundaries is the first step in the actual building process. Once the site has been pegged with metal or wooden pegs by a surveyor, the building itself needs to be set out onto the site, within the boundaries and the building lines on the surveyor's general diagram. It's important to refer to the floor plan of the building plans and the site plan to establish how to begin setting out the site. You need to ensure that the building faces the correct way as it is outlined on the approved site plan. The building is set out on the correct stand. It can happen that the site is set out on the wrong stand, so remember to check. The dimensions on the site are the same as the plan dimensions, and the building is set out within the required building lines. The following method refers to a conventional concrete strip footing foundation. Once the building is set out, you can begin laying out the trenches that you will use for the foundation. You'll need profile boards, which are used to create a 3-sided rectangle and placed in the ground to show the width of the foundation and the width of the foundation wall. A string or line is attached to the profile board to clearly indicate the measurements. The process is as follows. Put up the profile boards on each corner for the exterior walls. Place them close to but clear of the building walls. Put out profile boards for interior walls. Measure off the width of foundations at each corner. Knock a nail into the top of each profile board for each side of the foundation and put up profile lines. Mark the ground under the profile board line with a spade. Remove profile lines before digging the foundation trenches. When you begin digging the trenches, make sure the sides are straight using a straight edge or a square. Make the bottom of the trench as level as possible using a spirit level and compact the bottom. Then you need to knock the pegs, which are usually a metal reinforcing rod between 8 to 12 millimeters in diameter, into the bottom of the trenches, spaced at every 1.5 meters. The concrete must be poured at a minimum of 200 millimeters. Check that the pegs are level using a spirit level. Now it's time to pour the concrete. Remember that there are different strengths of concrete required for different uses. Normally, concrete cube strength tests are done by a contractor. An NHBRC inspector can request certain material tests to be done if poor quality is suspected. This table shows different concrete strengths. Low strength concrete, 5 megapascals to 15 megapascals, is suitable for unreinforced foundations for a single story, infill concrete in masonry and mass concrete. Medium strength concrete, which is 20 megapascals to 40 megapascals, is for reinforced foundations, beams, slabs, floors, domestic driveways, and footpaths. High strength is 50 megapascals and more, which is for precast items and high-stressed concrete. Make sure you pour the concrete in one day. Pour the concrete to the height of the pegs. Ram the concrete down into corners with a stick to get rid of air bubbles and spaces. Level the concrete to the top of the pegs with a board. You can use a piece of timber. Leave the foundation concrete to cure for 3 days before building on top of it. Now you are ready to build the foundation walls. First, check the foundation is level using a spirit level. Mark the position of the wall onto the foundation concrete. Mark a point and then draw a chalk line across the foundation. Set up profiles at each corner with the correct brick or block gauge to a height of 200 millimeters above the highest ground level. Build up the foundation wall starting at the corners. As you build, use a spirit level to make sure each brick course is level. The top of the corners must be level with each other. After you have built the corner, build the walls. The foundation walls must be a minimum of 200 millimeters above the highest ground level. Remember that there are minimum thicknesses required for foundation walls. Once the foundation wall is completed, you can begin backfilling and compaction. Use sand and hardcore fill. Make sure there is no grass or vegetation in it. Fill in the trenches on either side of the brickwork and compact it as you go. Make the sand moist so that it compacts well, but don't make it too wet. As you know, different types of soils and buildings require different foundations. Here are some examples of different types of foundations, all in accordance with SANS 10400 Part H. 1 brick wall strip footing with floating surface bed. Note that the key on this image highlights additional functional standards, which are expanded on in the SANS collection. 1 brick wall strip footing. Half brick internal foundation. 1 brick internal foundation. 1.5 brick wall foundation. Cavity wall foundation. Thickened surface bed foundation. Raft foundation. Internal raft foundation. Reinforced ground beam foundation on concrete piles. Once the foundation walls are built and you filled in the spaces, you should be left with a level surface. This is known as a surface bed. Make sure it's all compacted well, ready for the next step. Now it's time to lay the damp-proof membrane, also called undersurface membrane, which is a green plastic sheeting. This needs to cover the entire surface bed from edge to edge. Where there are joins, make sure that each joint overlaps and is taped closed. It is very important to remember that damp proofing must be everywhere, and vertical damp proofing, known as damp proof course, is essential. If there are steps in your foundations, be sure to damp proof upwards as well. Once that's done, use steel weld mesh to create a reinforcement layer. Even if this hasn't been recommended by an engineer, it's always a good idea anyway to ensure your surface bed is as strong as it needs to be. Before you pour, make sure all the electrical and plumbing conduits are in place, otherwise you'll have to cut the floor slab, and this could damage the damp proofing as well as reduce the strength of the slab, causing it to crack. Now you can pour the concrete floor slab. Make sure this is done in one day. If it's a large house, you can pour it in sections, but make sure breaks are at logical points, per room for example. Once the concrete is poured, use a straight board to level and compact the concrete. The superstructure is the bulk of the building and covers everything from the top of the foundation to the roof height. Before you begin to build the walls of the superstructure, a damp-proof course must be placed underneath the walls as per this image. Then you need to ensure you have the correct mix of mortar for the type of brick or block you are using. Mortar is defined in two classes. Class 1 is for masonry that requires additional strength, which includes high-strength structural units such as multi-story buildings or load-bearing walls and reinforced masonry. Load-bearing walls must be able to withstand their own weight, imposed weight such as a person standing on the wall, as well as the strong wind. Class 2 is for non-load-bearing walls like parapets, balustrades, retaining walls, freestanding garden walls, and other walls that may be exposed to extreme damp. A load-bearing wall is a wall that has weight on it from above. This table illustrates the different mortar classes and mixed proportions. There are different types of bonds and joints in bricklaying. With joints, toothing refers to removing a full or half brick from every second brick course as shown in this image. Collar joints are a joint no bigger than 20 mm between two walls to form a double brick wall, as shown here. A bond is a type of layout for placing bricks on top of each other, and the most common is stretcher bond, as shown here. English bond is less common, with one layer using bricks laid long ways and the next layer with bricks laid widthways, as indicated in this image. When beginning the superstructure brickwork, build up corners first. As the corners are built up, you need to be sure that the height of the corner is not more than 900 mm higher than any part of the wall to avoid unequal settlement, as this image demonstrates. Window and door openings shouldn't have an impact on the strength of the walls. This image shows how windows and doors can be built into a wall correctly without affecting the strength of the wall. This image highlights a typical one brick external wall as per regulations set out in SANS 10400 Part K. You'll see that brick force is required every 3 courses to ensure stability in the wall. Note that a minimum of 4 courses are required above a lintel. Before you get to the top of the wall, it's necessary to build in roof ties, also known as roof anchors. The type of roof tie used depends on the type of roof to be installed. These are classified in SANS 10400 Part K as Type A, 2 strands of 2.4 mm diameter galvanized steel wire. Type B, 30 mm by 1.2 mm galvanized steel strap. Type C, 30 mm by 1.6 mm galvanized steel strap. The type of roof, heavy or light, also dictates how deep the roof tie needs to be, from 300 mm up to 1000 mm. For example, a light roof requires a depth of 600 mm on a solid wall. Here you can see the fully built superstructure walls with roof ties in place. The roof plays a very important role in the building and must be designed by an engineer. In fact, the local authority won't issue a certificate of occupancy without an engineer's certificate stating that the roof complies with the standards. Some aspects an engineer considers when designing a roof is the weight of a roof, external loads, spans, design of the trusses, and its fixing. Roof configurations change according to the floor plan, but here are 4 common types of roofs. Gable end, hip valley gables, hip, monopitch. The example house in the video has a hip valley gable roof. Roof trusses are designed according to the type of roof covering that will be used. Two common types of trusses are Howie and Fink. There are two ways to deal with trusses. One is to make the trusses on-site. These must comply with the deemed to satisfy requirement for nailed and bolted trusses according to SANS 10400 Part L, or must be designed by an engineer or other competent person. The other way is to use a prefabricated truss. There are numerous truss manufacturers in South Africa. This is an image of a typical engineered truss, nail-plated. And here's a typical detail of a roof truss in line with SANS 10400 Part L. Trusses should be protected against any damage on-site before they're erected. They should be stacked on level ground on timber bearers and covered to protect them from rain with adequate ventilation while they are being stored. When handling trusses, care must be taken to avoid any damage to the timber and to the joints. Roofing isn't just about trusses, but also about the roof covering and its related aspects that prevent roof leaks. Factors that are vital to prevent water penetration are the design and construction of the brickwork in roof, quality of the roof covering and its fixing methods, underlay and flashing. These requirements are covered in SANS 10400 Part L. Some of the most common types of roof coverings are concrete and clay tiles, which fall under the heavy roof classification, and metal roof sheeting, which falls under light roof classification. Flashing is a term that refers to thin pieces of galvanized metal sheeting that needs to be installed correctly to prevent water from going into a structure and is a critical part of ensuring that a roof or home doesn't leak. Site leveling, gutters, and downpipes help to move stormwater from the roof down to the ground, and a concrete apron helps to steer water away from the home's walls. To summarize, as a home builder, you need to be registered with the National Home Builders Registration Council and keep your registration current. Any home you build must be enrolled with the NHBRC at least 15 days before you begin building. The NHBRC offers enrolled homeowners a warranty scheme that covers 1-year roof leak, 5-year major structural defects. That concludes this episode. Thank you for watching. Remember, the NHBRC has published 3 different books to assist you in complying. The Home Building Manual, which has 2 sections, the manual and the guide. The SANS collection for home builders, which outlines all the building regulations that you need to work with. And the Simplified Home Building Manual. These books are available to all NHBRC registered home builders, and it is recommended that you use these books as a reference on all building projects. Until next time, goodbye.